Hess'S Law. Now, a Swiss scientist, Germain Henry Hess, observed that the heat evolved or absorbed in a chemical process is the same whether the process takes place in one or several stages. This is known as the law of constant heat summation. Consider substance A being converted to B through this path, or A being converted to C first and then C to B. Either way, A has been converted to B. According to Hess's law, delta H is equal to delta H1 plus delta H2. Hess's law is simply a corollary of the law of conservation of energy. It implies that the enthalpy change of a reaction depends only on the state of the reactants and products and not on the manner by which the change is brought about. Consider the formation of carbon dioxide from carbon and oxygen. There are two ways in which this change can be brought about. A. Conversion of carbon to carbon dioxide. Or B. Conversion of carbon to carbon dioxide and subsequent oxidation of carbon dioxide to carbon dioxide. According to Hess's law, delta H is equal to delta H1 plus delta H2. Negative 393.5 kilojoules must be equal to negative 110.5 plus minus 283.0, and that is indeed true. Hess's law can be used in determining the heats of formation of certain compounds which cannot be synthesized directly from their elements. These include methane, ethane, sulfur 6 oxide, and others. For example, let us consider the formation of sulfur 6 oxide. Direct formation of sulfur 6 oxide cannot happen, but we can convert sulfur to sulfur 4 oxide. We can also oxidize sulfur 4 oxide to sulfur 6 oxide. With these two thermochemical equations, we can calculate the heat of formation of sulfur 6 oxide. Delta H is equal to delta H1 plus delta H2. Negative 297.4 plus minus 97.9, and that gives us negative 395.3 kilojoules. Now, consider the formation of methane. We cannot be able to measure the enthalpy of formation of methane. The theoretical formation of methane would be combination of carbon and hydrogen. However, if the reactants and products are burnt in oxygen, they will give us the same products. And therefore, we can be able to calculate the heat of formation of methane by considering the formation of water and carbon dioxide from the combustion of hydrogen and carbon given their heat of combustions as follows. The theoretical formation of methane from carbon and hydrogen would take this path. And then the combustion of methane in oxygen would produce carbon dioxide and water. Combustion of carbon in oxygen will produce carbon dioxide, and combustion of hydrogen in oxygen would produce water. So whether you follow this path or this path, you will end up with the same products, carbon dioxide and water. And therefore, the enthalpy changes must be the same, so we can calculate the unknown. Path 1, that is delta HF plus minus 890, must be equal to path 2, that is minus 93.3 plus 2 moles of hydrogen, so 2 times minus 286. So delta HF minus 890 is equal to minus 393 minus 572. Delta HF is equal to minus 393 minus 572 plus 890, and that gives us minus 75 kilojoules per mole.